you. Hello everyone, welcome to this presentation called Secure My Socks. This is a presentation that's a bit more technical than some I've seen over the past couple of days. So if you feel like that's good, then great. If you're more interested in the agile stuff, then please don't throw tomatoes at me. Just ask questions at the end if you have an issue with it. So the idea is that I'm going to show you a couple of live demos, fingers crossed if the demo gods are kind to me. And I'm going to talk about microservices security. In particular, I'm going to talk about security in containers and security in orchestrators. If you're not aware of any of those concepts, then don't worry. I will sort of rush through it quite quickly, but I'll try and explain it as I go along. So let's get cracking. So before my clicker doesn't work, before we start, there we go, we're working again. Before we start proper, I always do a quick search to see whether anybody has named their presentation, something that I'm calling my presentation, so we don't get any conflicts there. And I found this little website here called socklocks.com. And apparently in the US, one of their major problems is losing socks in the wash. So what they've come up with is this sock lock contraption here. Now, who would have thought that keeping socks in a similar color, keeping socks separate in the wash? Forget it. It doesn't matter. You get the point. It was a joke. I can't even say socks at the moment. I must have been out too late last night. I'm going to bring in with a little bit of context, and I like to use an example to guide why we do security. And one of the best examples of why we do security is because people enforce security principles on us. There's a set of auditable techniques called PCI compliance, payment card industry compliance. And these are a set of rules that you need to abide by if you want to handle credit card information. You know, if you want people to pay for your services and you're writing the services to handle the transaction of money via a credit card, then you need to be able to be auditable by people that enforce PCI compliance. So how do people generally do that in business? Well, there's kind of two ways of doing it. And actually, we can summarize it even further. It's basically, do you or do you not trust the developer? If you can answer that question, then you come up with two answers. If we assume trust, then we can take a lot of the pressure off the developer because we assume that the developer is always going to do the right thing, so we don't really need any fail-safes in there to protect the developer from doing the wrong thing. And that's fine, but then the issue is if you want to become PCI compliant, you then need to audit like mad. Basically, you need to interrogate your software and make sure that you can prove that it is safe to somebody that is auditing you. And the issue with that method is that only large companies can tend to afford to do this because they need large departments that are capable of performing these audits continuously. If you're a small company, then generally a handful of developers, a handful of other people, that's kind of not possible. And this is kind of where DevOps starts to fit in as well. So we have all these ideas of being agile and following DevOps and giving developers the want and the need to be not only interested in the development of their software, but the wider use of their software as well. So how, as a company, can we attempt to minimize the compliance measures that we need to achieve? And the first one is just simply by limiting the surface area. And this is how we come to microservices. If we can start to limit the surface area of a service, then we can start to reduce the attack patterns that are possible within your application. So if you have a monolith with hundreds of different API endpoints, something like that, then there's a handful of different routes that an attacker could get in. But if you've just got one simple, single API input and output, then the attack service becomes much reduced. And we'll come back to that later on because part of the talk is about network security. How you can secure your network to make sure that there are very small numbers of inputs and outputs. But even if you do achieve PCI compliance, this is just one general area. It's only to do with payment card information. It's not to do with user data, whether you're going to get hacked, things like that. And just as a funny example, this is from Stack Overflow. And somebody was using Docker on one particular day. This only happened on one day. And Docker is a company that basically pushed containers into the mainstreams, and they are de facto DevOps. On this particular day, for some reason, when you entered any password, even if it was correct or the wrong one, the Docker registry, the thing where you get your containers from, just responded with "fuck you." It's not very nice, but I can only assume that what happened was that some disgruntled employee decided to, put this little time bomb in there and then left because it was gone, very quickly. But it just goes to show that even with companies that do stylize themselves in, doing all of these modern things, modern technologies, it's still very hard to be secure. And it's not that it's actually difficult to do. It's just next to impossible to say that you are secure. In fact, if you go out and say that you are secure, you're just asking for someone to prove that you're not secure. So I'd recommend not doing that at all. And and it's also hard to begin as well because it's hard to know where to start. And in the beginning, I like to approach it as something I call failure exploration. And it's basically imagining everything that could possibly go wrong with your service, with your container, with whatever it is that you're doing, and explore as many avenues that you could imagine and mitigate against those. And then get somebody else to do it, and then get somebody else to do it, and so on and so on and so on. And over time, you can build up this defense and depth. You can build up this defense to be more secure than you would be if you acted alone. And when you start thinking about some of the things, there's actually loads. There's especially even if you just focus it down on something like containers, there's a whole host of issues that we need to consider. And today, I'm not going to try and talk about all of them because it's too difficult. So I'm going to talk about network segmentation and policy, so basically network security, and container security, because they're quite interesting things to demo and they're quite fun as well. So to do this, the reason why we created this project in the first place was about a year and a half, 18 months ago, a year ago, something like that. I was working with a company called Weaveworks in London, and we were developing some services to help developers be more cloud native, help them produce and deliver microservices. And we found that there were no real examples on the internet. The kind of examples that were there were just like in the form of blog posts or something, and they were very simple and very noddy, maybe one or two services, it's a simple database web app type thing. So what we set out to do was to create a more realistic example, and we came up with an e-commerce reference application that we called the Sock Shop. And we called the Sock Shop because we are selling socks. And this is it. Actually, I'm not going to browse to it now, but basically it's a proper e-commerce store. You can browse the catalog, you can log in as a user, you can check out into a cart, you can manage your order history, all of the things that you'd kind of be used to, that you would be used to doing in a simple e-commerce shop. But the beauty is that it's all constructed and created as a set of microservices. So you can really see the components and the code that go in constructing these individual microservices. And I'll put this link up at the end, but if you search for microservices demo on GitHub, you'll find it. Also, there's a short link, git.io/sockshop. Okay, let's crack on with the meat course, container security. So there's like I said, there's a host of things that you can do to improve your container security. And the most important thing you can do is restraint. You can restrain the user of the container to only do certain things. So, for example, if we knew that our server, for some reason, if you needed to do this, but if you knew that this container didn't need to access the outside world, you could restrict all network traffic. If you knew that it wasn't allowed to access the file system, you could restrict the file system. And it's this act of restraint that you're basically shackling the hacker's hands. If they don't have access to the things that they need to do to do their damage, then we're all good. The next one is immutability. if we can remove all form of mutability, all form of state from the containers, then there's no way that the attacker could alter that state to produce some secondary effect. So, for example, if you had a container that was read-only, for example, then an attacker can't come in and overwrite your content with his own or her own. Provenance is the idea of trying to prove where your container has come from. And there's some quite simple things that you can do, actually. So with container runtimes like Docker, you know, when we do a Docker pull or a Docker run or something and we type a name of a container, instead of relying on a tag, you know, something as ridiculous as latest, whatever the hell that means, but even instead of relying on something like a version number, you can actually refer to the hash, and the hash is defined by the contents of that container. So if you request a specific hash, you can be certain that you're getting the right container for you. As opposed to if you get a tag, then maybe someone has accidentally pushed to that tag and broken it or something like that. So there's kind of simple things that you can do. There's also other services out there that you can use to verify and scan containers to make sure that the things that are inside them are actually there, and you know, the things that are not supposed to be there are not there. And then we get into things like hardened OSs and modules and things. So you get certain Linux distributions that are hardened by default, SE Linux, things like that. So check into that. But I think I'm going to talk a little bit about restraint and immutability the most, because that proves for cool demos. So the first one is if you haven't set a user. Oh, actually, let's just take a look at an example first. Yeah. So this is one of the Docker files. So a Docker file is a thing that defines your container, your Docker container. And Docker will go through this and take each step and then build a container from each step. This is the code to define that container. And I can say that this code is shit because it's my own, so I'm not offending anyone, so we're all good. And in this code, we haven't set a user. There's a command to set a user. And if you don't set a user in your container, it defaults to being the root user. And the root user is usually allowed to do anything. So let's go and have a look at some real-life demo. So over in another browser window, where's that gone? There we go. I have a version of the sock shop running on my local host, and it's, you know, it's equivalent to the version that's running on all the environments we have, but this is the one that's running on my laptop. I'm going to go over here, and hopefully you can see this. And I'm going to execute into the front-end container. Okay, we're good. And hopefully, if it's still there, excellent. So what I'm going to do, because I haven't set a user, I'm allowed to install and run applications as if I was root. So I don't know if you could see that, but it was a pretty picture of a train. And I do like that train. I'm going to run it again, actually. I enjoy it so much. There we go. But you can imagine that could be a Bitcoin miner or you know, anything more nefarious than a pretty ASCII steam train. Another thing that we could do is, again, in this Docker file, we haven't set the container to be read-only. And the way that we define a container to be read-only is actually in the orchestrator. It's not something you can do in the container itself. And for the version that I'm running on the laptop, I'm using Docker Compose. And in the Docker Compose definition, I haven't got any read-only definition at the bottom. So it means that I can go in and go into that container again, run some code. There we go. And what should have happened is I've just overwritten the index. Yeah. So, you know, if this was a real-life website and you hadn't set read-only on your container, then anybody that has access to the container can simply overwrite it with anything they want, you know, and that's how a significant number of phishing attacks occur. Okay, so that was that. And then finally, we've got another one. So we can actually start to talk about restraining some of this. We can start restraining the attacker by saying, you know, don't run as root, you know, set a user. We can start restraining him by read-only, set in read-only, so you can't overwrite files. But the Linux kernel's got a really cool feature that's underused throughout all of IT, not just within container land. And they're called capabilities. They are a kernel-level feature that prevent you performing certain kernel operations. And the problem with capabilities is that you never quite know where to set them. So sometimes you don't know whether you're in the container or whether you're in the orchestrator, but in reality, it's actually somewhere in the middle. You're actually setting the capabilities on the kernel itself that's running the container. So on the host machine, yeah. So generally what you can do is you have to do some permissions in the container and some permissions on the orchestrator. So in the Docker file for the catalog service of the microservices demo application, there we can add a user by running. So let me step back a little bit. So previous to me writing this code, we used to run BusyBox, and BusyBox is a really, really super small Linux kernel that is used quite often to run applications in containers. And it's nice because you still get some of the kernel capabilities inside the container, but it's super tiny. It's like a megabyte, a couple of megabytes or something. So you end up with really small containers, which is good. BusyBox has a Linux command called add group and add user, and we can add the group and user like so. But if we want to start messing about with capabilities, BusyBox doesn't come with tools to play with the kernel features that are capabilities. So for this case, I swapped to Alpine. So Alpine is another container that you can base your images from, which again is still very small. It's only about 5 megs, something like that. But it comes with a much greater tool suite that you can use. And most importantly, it's got a package manager. So it's really easy to install things. So what I'm doing here is I'm installing a library called libcap. And inside that libcap is an application called setcap. And setcap is something that we can use to assign capabilities to a binary inside the container. So what we're doing here is we're saying we're going to only give this binary, this /app binary, the capability to bind to the network. And this is just kind of syntax to make that happen. So what we're doing there is we're only giving that binary the capability, the permission basically, to perform one single thing. It can't do anything else. So we're hugely restraining that application. So if that application was something that was quite complex or something that somebody could get access to, maybe it's some sort of runtime that's running inside your container, and a hacker could maybe get access to that runtime and then use that runtime to do something on the outside. If they did get access to that runtime, in this case, all they would be able to do is to bind to a different port. That's it. That's the worst thing they can do. The other side is applying capabilities to your orchestrator. And we do this in Docker Compose with these two commands, cap drop and cap add. So again, basically we're replicating what is allowed by the binary. We've got a cap drop of all, so we're dropping all capabilities possible, not allowed to do anything, and then we're adding back one. We're just adding back the ability to bind to a specific port, in this case lower than 1024, so binding to port 80. And also, I mentioned read-only, so we're altering that Docker Compose file to read-only. So, oh yeah, just before I go on and try and demo that, I'll just talk about Kubernetes as well, because we'll demo Kubernetes later. Kubernetes is another orchestrator. It's much more comprehensive and feature-packed, and things that I find in a similar way. You have a capabilities section, and you're adding the specific capability you want and dropping all the rest. It's got a read-only file system, just like Docker Compose. Kubernetes also has this cool little feature called run as non-root. And this is a feature to get Kubernetes to check for you that the container is not running at root. So if it is running as root, maybe you forgot the user, Kubernetes won't start it. So that's a nifty, neat little feature that is only available in Kubernetes. Okay. I think what we're going to do, right, let's see if this works. So now I'm actually on an insecure branch, and I'm going to switch back to master, and then I'm going to, oops, compose, up D. Oh, damn, it's pulling another container. I probably should have done that before I started the talk. Come on, quicker, faster. Oh. Probably quick enough to wait, just. Come on. Oh, it's pulling other things as well. Oh, okay, I give up. That's enough. Sorry, I should have pulled all those containers before I started. But what would have been the result there is that in those newer versions of the containers, we've got the capabilities in there. We've got the read-only file system in the Docker Compose file, and so on, and so on, and so on. And if I was to try and run those commands again, it would say, access denied, you're not root. When you try to install something, it said access denied, you can't overwrite that file because it's a read-only file system. And if we tried to do anything else with the kernel, it would also say access denied, you don't have the capabilities. So, secure. Okay, so top tip number 2, this is set the user. Just always set the user. It's a really simple thing to do. If you don't do it, just do it to all your containers to begin with. That will significantly significantly improve the security of your containers. Read-only is also another very simple thing to do. It's just one line in the orchestrator. Just do it. Capabilities are a little bit more difficult because you actually have to figure out what capabilities you need before you apply them. So generally what you'd do is you would start off with your application having all capabilities, and then remove as many as you can until it stops working. Once it stops working, you've removed something that you need. That's generally kind of how it works. If you can use them, though, definitely do it because it's just yet another layer of security. Okay, so let's have a little intermission. Did you know that nearly 12,000 people in 2003 were hospitalized due to SOCs? So SOCs are actually really dangerous, and I think there should be more. Nah, forget it. I was going to try and make a joke, but I'm not going to bother. That in itself is funny. 12,000 people are hospitalized due to SOCs. Crazy. Network segmentation and policy. So what I didn't really tell you about was the structure, the organization of the application. And it looks a little bit like this. We've got a front-end service which acts as both a static web server that hosts content, and it's also an API gateway to the rest of the services. In the back end, we've got all of the things that are required by the various parts of the e-commerce business. We've got a shopping cart, a catalog, a user, payment, order, so on and so on and so on. Some of those are backed by databases. We've got some other interesting things in there like queues, yeah, that's about it. So it looks like that. And the first thing that we would do in our failure exploration is to try and figure out where people would like to attack from. So what we would normally do is consider, how would people get access to our application? So if we just run this on a completely public server, then anybody would have access to any of the containers on any of the ports. So what we can do is provide some sort of firewall to prevent that from happening. But it's not just any old firewall. It's got to be a Trump firewall, which is bigger, better, stronger. This joke probably went better about a year ago when I first started doing this presentation, but I still think it applies. It's still in office. I'm not sure why it's still there, but he would build a bigger firewall. And that's okay. That goes so far as preventing people accessing your systems from the outside. But quite often, and then they're generally not sort of nefarious accidents. They're not accidents that cause any damage or harm. They're more just sort of cross-cutting accidents. And what tends to happen is that some services accidentally access other services when they shouldn't be. And that that introduces coupling. It's basically a bad software practice because it makes your metrics of your software quality worse. And a simple firewall won't help you. So we need something a bit more fine-grained. So what we can start to do is to start to segment the network. So, especially if you're in the cloud, it's very easy to do. But even if you're on premise or something, you can start physically disconnecting the networks and only connecting those that need to connect to each other. So in this particular example, if we applied network segmentation to the different layers of the microservices architecture, we can totally decouple the external network from the back office network. And so if we did try to access the shipping container from the front end, it would just be blocked on a network level, So there's kind of nothing to worry about there. And it's quite easy to do that, especially in Docker Compose. We can basically assign a particular container to a network, and that's it. But another thing that can happen is you sometimes get in the same level, the same conceptual domain. You can have services that are trying to, or accidentally trying to communicate with other services, like the catalog communicating with the cart. And this is we've got to keep going back to the reason for doing this, and the reason is to make the containers more secure. If somebody had access to the catalog container, don't just imagine that they did. Don't worry how for the moment. They shouldn't be able to access the cart. The catalog has no reason to access the cart. So it shouldn't be allowed to access the cart. And even with our segmentation example there, we're still in the same network here. So the catalog can still access the cart. So it's not fine-grained enough. And just to demonstrate that, I'm going to go ahead and try it. So another instance that I have running is one running in the cloud on our staging environment. And again, I'm going to exec into the pod you can't see, but I think it was, it was the catalog. And I'm going to telnet, because telnet's installed, the carts service on port 80. Gonna remember the syntax here. Carts 134 0. Yeah, and you can see that the cart at the moment. Hopefully you can see the contrast isn't great. But what happened there was I telnetted into the carts application. I called the API, and I was able to get back some important customer information. That should not be possible because there's no reason for the carts to connect that. So what we can do is use something called network policy. And this is something that's very specific to Kubernetes, and I'm surprised that other orchestrators haven't caught up with this, but I think it's a really neat feature and very simple to implement. All it is basically is, have we got an example? Yeah. Again, it's a specification specifically stating what this container is allowed to access. It's as simple as that. We're saying that the pod, for whatever this is, the shipping container or wherever it's from, is saying that the shipping container is only allowed ingress from the orders service on port 80. All other communication will be blocked. So I can go ahead and apply that. Hopefully it's in my, yes, it is. I think that's done. Yep, so what I've just done there is I've just applied a whole swath of other policies which are defining which service is allowed to access each other. And now if I exec into that pod again, and I do telnet carts 80 again, get carts 134, 0. There we go. It would just hang there indefinitely because the Kubernetes policy, the network policy that we've described, is not allowing this service access to the other service. Okay. But the important thing to remember with all this is that for most of the orchestrators, all of this magic is happening kind of under the hood, away from your eyes, and it's all been enabled by a software-defined network. So it's a network that's controlled by a software definition. If you don't have that, then you have to do it manually, and that is generally a lot harder. I mean, you can still do it, but I would certainly invest, or at least investigate, a software-defined network for your applications. So I think we're about time. Oh, I'm actually super early. Oh, sorry about that. It's probably because maybe we could redo that demo in the end. But what I've basically done is just looked at the two distinct parts of the security landscape. We've got the container level, where we always set a user. It's very simple to do. We make it immutable if it is immutable. It's very simple to do. And we restrain it with capabilities. Less simple to do, but once you've done it once, it's done. And then when we talk about networks and network security, firewall everything, from every level. Firewall the entire application, firewall the individual networks, firewall the individual services. If you've got firewalls at many different levels, they're just extra hoops that the attacker has to jump through in order to get access to your application. So again, visit that link there. And the thing, actually, let's just take a couple. I've got loads of time, so I'm going to just take a few minutes looking at this. If we go back to the actual website here, the coolest thing I want to show you is that inside the microservices demo, I've talked about Docker Compose and Kubernetes, but we've actually written deployments for a whole host of different orchestrators. Some that don't really exist anymore. I think we've got rid of some of them now. But Kubernetes is just one of the biggest, but we've also got a Mesos implementation as well. So if you're interested in comparing the differences between Kubernetes and Mesos, give this a try and use this as an example. We've got one for Nomad. Nomad's really cool. Nomad is by HashiCorp, and it's like a shrunken down orchestrator. It's really cool because the management of all the different nodes is done via the Raft protocol. So it's not a traditional master-slave like master-slave architecture like Mesos and Kubernetes is, which makes it really simple to install and run because you just start up another server, run the binary, automatically finds its peers, and we're done. So yeah, Nomad's cool as well, just not quite as feature-packed. We've got some AWS deploys there as well, and obviously the Kubernetes deploys works for Google Container Engine as well, and some Apcera stuff as well. So certainly check that out, especially if you're interested in orchestrators. It's a really neat way of comparing the different orchestrators. So yeah, it's there, and I think I'll probably end it there. So my name is Phil Winder. I have my own data science cloud native consultancy. This wasn't very data science-y, but I'm definitely interested in the data science as well, and I'd love to talk to you afterwards. So I think I'll probably stop there and answer any questions if you've got any. If not, I'll maybe try and do that demo where I was downloading those containers earlier on. Okay, thank you very much. So if we've got any questions, yes? Yes, that's right. Yeah, this all C. Yeah. I mean, the Enterprise Edition is. I can't quite hear what the question is. Can you try and either come closer or shout a little bit louder?
Okay, so like any pointers on Enterprise Edition of Docker, because community is not available.
I mean, to be honest, the enterprise version of anything is basically just support. You can get all of the functionality in most of the enterprise editions in the free, versions. If they're not supported in CE, they're usually provided by third parties. So my recommendation is don't use enterprise support unless you actually need the enterprise edition support. So all of that stuff all applies to the community edition stuff. It also applies to the enterprise edition, but there's no point talking about that because I'm talking about the technology, not the support services that these companies provide. So that's kind of a roundabout answer to your question, I'm afraid. Yeah, sure.
What service are you using for scanning containers?
Yeah, good question. I forget actually because they've changed over time. So Docker has had one and released it publicly, but then moved it and made it private. Exactly, moved into the enterprise. But I know that Key, have you heard of Key? So QUAY.io. They're a registry, they're a Docker, a container registry, and with their free offering, they offer a simple sort of scanning support. There are also a few more third parties, which I can't remember the names of, unfortunately. But yeah, check out Key. Key's pretty cool as a registry anyway. Yeah, there you go, CoreOS Claire, thank you very much. And that's another open source one, yeah. I think that's one that you've got to run yourself, right? It's not a hosted service. Yeah.
It basically powers the Quay or P1.
Okay, I didn't know that. Okay, cool. Thanks, Daniel. Any more? Yeah, jump in back.
Testing your configuration to make sure that you don't suddenly open any holes. What do you use for is there like can you do a test-driven approach to saying, this port is not serving that?
Yeah, sure. Good question. So,
like in support, sometimes you need to install something to allow you to debug certain things when they occur. So do you open them up, debug them, throw them away? Do you allow certain access, but under what? How do you
yeah, there's a multifaceted hydra of questions there. So let's step back a bit. So the whole idea of test-driven development and DevOps is to guarantee that the things that are going into production work as you expect them to work. So the ideological answer to that is that everything should work before it gets deployed. You should never need to debug in production. You should never need to open up services to do debugging because they should already work. And it's kind of ideological, but it is a good place to aim for. And the way that you would get there is by using things like continuous integration, continuous delivery, and tests, basically. You have the array of tests that ensure that your application does what it's supposed to do, but in particular, if you're worried about penetration testing, then you would have to automate your penetration tests. So at a container level, you can imagine that if each container was a service and it had its own continuous delivery pipeline, that at the end of the testing, all the normal testing phase, the unit tests, the integration tests, there would be a final one called penetration tests or something, and that could be something as simple as a script that's just looping through ports saying all of these ports should not be open. Or, I'm sure there's more sophisticated tools out there that would actually actively try and penetrate your container.
About the application is more about how do you test the infrastructure? How do I know that this port, when I'm inside,
Yeah.
I have access in this container.
Right.
This thing, because I can't observe it from the outside.
Yeah.
So I can't get in to call it. Or
Yeah.
But I've got like a mock service in between that I can talk to on one port to say, can you get out from here outside? Because obviously you've got to assume that someone can get on the box and they need them off, that kind of thing. It's more about testing the infrastructure and the configuration of the ports and security capability.
Yeah.
Rather than the application running on it, which is easy to stuff.
Okay, well, I would argue that testing the infrastructure is just as easy. So the way we do it in SOC shop and also in production systems, we have a separate environment that is specifically suited for doing these types of tests. So at the end of our container level tests, we then have another phase where it goes into a deployment test. So we deploy it to like a staging environment, and then inside that staging environment, we would run another container, maybe an external service, something else, which would then fire requests, reuser requests, penetration requests, anything that you would assume. And that is where that you can really test automatically whether your infrastructure is then secure. So you're basically creating this possibly temporary set of infrastructure that is used for that one particular test. So some people go so far as spinning up VMs, just for that purpose and then destroying them once the test is done. It just depends how you want to do it. The way we've done it in this case is we've just got one single staging environment that we keep alive all the time, and the tests deploy to that staging environment, do some simple tests, basically does it still work? And then if it still works, then it says that container is ready for production, gets deployed into production. So that's kind of more of a continuous delivery approach than anything. Okay, thank you. Yep.
In your demo,
Yeah.
you're able, from one container,
Yeah.
to be able to access another container without any extra authorization.
Correct.
So do the containers implicitly trust each other, and there's no need to say, I am definitely from this container?
Yeah.
Inside of the firewall, everything's trusted.
Yeah, exactly. So it depends entirely how you architect your application, but generally there's not. I would say that generally there's not much point in enforcing such strict security standards on services that are only ever meant to be internal to your application, because it's an extra overhead, or in terms of the amount of processing capability that's able to do, but also in terms of complexity and code complexity as well. If you start adding authorization and access control and stuff to your application, that's a lot of code that you need to add, when it could be something as simple as, some of these services are just DB-backed REST APIs. Put this item, get this item, that's it. So yeah, in that example, that container didn't have any authorization stuff in it. It was just open, it was REST API and port 80, so I could access from another container. So it's this idea of trust. Do you trust your developers, your applications, to do the right thing? If you don't, if you have a massive team and they're totally distributed and not communicating together at all, then maybe it might be necessary to be a bit more strict about that trust. And then you would maybe implement something like you're suggesting. Okay. Anyone else? Okay. Thank you very much. I think, we'll stop there. We're near enough to the end time, so thanks a lot.